Hello, I'm Cuauhtemoc Sanchez Rodriguez. I'm Mexican. I'm part of a group of Mexican researchers that have developed a molecular device to identify genes and biomarkers of inflammation, especially to be used with trauma patients. A microarray is a microchip device that you could use to identify the genes that you have already selected through a very specialized process, in which you can use 4 milliliters of blood that you draw from the patient, and then you pass them through this device, in which you have what we call hooks for the identification of specialized or selected proteins that will identify the genes. This process is very long and elaborate, and it allows us to show, or it shows us the relationships of those biomarkers and genes that are incorporated into the inflammation process, and we are able to identify with this chip 115 genes. What is the chip good for? It is very important because it allows us to identify the biomarkers that we think, and they might change not only in certain conditions or in certain cases, but also in different races. And there are some biomarkers that are more important for the Europeans and for the African or the Latin population. And it also helps us as a device of research. Then we can identify the genes that are working, and we can compare them with clinical references that we already have. When we use the chip, we can identify those genes that are overexpressed, those who are underexpressed, or those who have no change. And then we can make a comparison with other people and other problems, like in burns and trauma, when sepsis, and we can identify these genes. We can also identify dysfunctional specific metabolic pathways in these patients, and every day we identify more and more the importance of these metabolic processes and pathways in the inflammatory response. So at the end, once we have identified the genes that are more affected in this process, then we can adjust personally and precisely the medication or the treatments that have been already identified to modify that gene. So we can modify and be very precise in this process of treating our patients. How we select them, it's a very elaborate process that starts with a research and a search of all the inflammatory biomarkers that we have. Then we identify the genes of interest, especially those who have a 90% or above 90% of expression. Then we select them in a database. We look at a string for the molecular or molecules relationship. Then we select the identified proteins, and we chart these molecules relations. I'm very visual, and I like to see the charts in these figures more than the charts only. Once you have that table of molecules, you select a hierarchy in which you can use the percentage that you want to have expressed. So we know that we like above 95%, and we can select that. So we choose those. We select the highest that we have. We create a network that we go to cytoscape, and then we create our final process through tables and statistical processes to be able to come to our last one. And in this case, inflammatory response, we know the AKT is one of the most important kinases involved in it. So we tried this with 8 patients, our pilot study, and we were able to identify the responses, or the difference of responses of the genes, those who were underexpressed, overexpressed, and those who have no change, which are very specific and very interesting cases. So now we can identify them very precisely, and we're able to do a precise diagnosis and a precise medication for every specific problem. So we will see in the near future advantages of this once it's used more commonly in the clinic. Gracias, and thank you very much.